judges at Microsoft Azure Hackathon. My name is Wan Ning, and with me are my teammates Siti, Louis, Andrea, and Jinwoo. We'll be presenting our solution to the UNTP challenge. So I'll be starting with the problem statement. So this is Alex. With the increase in health and environmental consciousness in consumers, there are greater demand for fresher and sustainable food products. Alex wanted to seize this great business opportunity by starting an urban farm. However, he faced a major problem, which is the limited options in pest and disease control. Conventional methods like pesticide spraying might not be applicable due to the close proximity of the urban farms to the community, and soon Alex's crops could be infected with pests and damaged by diseases, resulting in the death of all his crops. Alex's efforts to grow an urban farm would have all gone to waste. But luckily for him, our team of tech enthusiasts have thought up of a safe, effective, and environmental friendly solution powered by technologies such as machine learning and the Internet of Things to minimize crop loss. So while coming up with this solution, our team have foreseen four major challenges, such as our lack of expertise in agriculture, the customization of solution to different varieties of crops, and a functioning machine learning model. So whether there's sufficient time and the availability of data sets for training it and the accuracy of the model itself. And lastly, the scalability and the maintenance of the IoT hardware. So while doing research for our solution, we came across some existing solutions meant to target this problem, such as hydroponics and aquaponics to reduce the instances of pests and diseases, the usage of drones to quickly distribute biocontrol agents that kills pests, and lastly, the advanced IoT monitoring system to track plant conditions. So after all this research, we have refined our machine learning and IoT solution according to the challenges and existing solutions we have gathered. So we aim to achieve these three outcomes for our solution, namely the real-time reporting of plant nutrition levels, weed pest and disease detection, as well as the ideal combination of nutrition and conditions that likely results in the growth of healthy plants. Moving on, the IoT hardware required for our solution includes Raspberry Pi, sunlight and humidity sensors, as well as soil moisture and pH sensors for measuring plant nutrition levels, and image sensors for capturing the images of weeds and plants. In the following slide, it will show a picture of our detailed architecture of our solution. So IoT sensors installed on the premises of urban farms will send image and nutrition data of the crop to the IoT hub in the actual cloud platform in real time. Then, image data are stored in a blob storage. The addition of new images to blob storage will trigger an event grid notification to be sent to an Azure function in Function apps. Azure functions would then send a link to the newly uploaded image to the custom region API for analysis. The custom region API allows us to customize pre-built machine learning models for performing weed pest and disease detection. Once the data has been returned from the custom vision API, Azure Functions will store the results of the analysis along with the image metadata in the Azure SQL database. Meanwhile, crop nutrition data are processed in real time by the Azure Stream Analytics job and stored in an Azure SQL database. Next, Azure Stream Analytics will make use of Azure Machine Learning to map the nutrition data to the corresponding labeled image data to identify the ideal range of combinations and conditions that result in the growth of a healthy plant. We'll do this using multi-class decision tree, but we might change it to other algorithms that have higher accuracy later during implementation. This result will be stored in the Azure SQL database as well. The next slide will show an hypothetical example of the ideal range of combinations and conditions that result in the growth of the spinach plant. Moving back to the architecture diagram, all the processed data results will be displayed visually in a dashboard for reporting using Power BI within a web application created and hosted by Azure Web Services. End users could then carry out actions based on this report. So what are the benefits of our solution? First, it helps to save manpower costs as IoT and machine learning can help to monitor the health of crops remotely and effectively, thus requiring lesser manual work. It is also scalable to be implemented in large-scale farms whereby it may be difficult for farmers to monitor the health of every single crop. And lastly, the machine learning can also help to find the best algorithm to determine whether a crop is healthy or not, thus increasing accuracy in the automation process. We've come to the end of our presentation. Thank you. And the following slide will show the photo credits